Hello everyone, this is PSpice tutorial for ELEC202. In this video, I will show you how to install PSpice, and I will do two examples with simulations. Let me start right away with how to download it. This website is electronicslab.com. When you scroll down, there is this PSpice 9.1 student version. You can download it from here, or there is another website. This website, let's say you can download the same thing from here. When you click this one, it just starts. But since I already downloaded it, I will use mine. Here, after you download it, this exe file comes. I suggest you create your own directory. For example, I can create mine in C folder under name PSpice, and I just copy the path and I paste it to here, and I unzip all the folders to here. Then I click this setup.exam, click yes. And I say, okay, if there is any antivirus program, you should stop it. I say yes. I want to also schematics, so I say click here and say next. Destination folder is important. This is where your files will be saved, so I also changed this to my folder. I say okay, next. Say okay, finish. Now this page comes up. I just close this one and continue. After you install your program, it will come to here, and you just click schematics. And here our board, actually, where we will do all the designs and simulations. This is our environment. Let me begin directly with our small circuit, the most basic circuit. Here there are some buttons, and I will show them while I design the circuit. This button here is the part browser basic, like there are basic circuit components here. For example, let's put a voltage source VDC. VDC is the DC current voltage source. I click place, or I double click on VDC here, for example. Let's click place. Then I have my component, and I can just put it where I want. I can put multiple of them, but there is no need, so I put only one. After you click place, this doesn't go away. You should either click on escape, or you should click on right. You should right click in with your mouse, for example. And then this is our voltage source. Then I can also add a resistor. I click R, and this is a resistor. I place this one too. I again right click. This is actually the basic circuit that we will use. These buttons here are for wires. I can draw a wire. I click this one and bring this one. This is just the connections. Actually, that's it. Now I should I can change the parameters of my components from here. For example, value of this resistor is 1K. I will leave it like this. And the name of the resistor, how we will refer this resistor, let's name it R1. If you have many resistors, voltage sources, and capacitors, inductors, then you need to, you may need to name them in meaningful ways. This is V1, for example. Let's make this one V in. And this is 0 volt. Let's change this to 10 volts. I can change the place of this this labels to like this. Okay. I can name the wires. For example, let's name this one also V in, and let's name this one V out. This will be handy in simulations, so I named them. Now, if I try to simulate, let's try, for example, before you simulate, the most important point is a setup analysis. Now, I should first set up how I will simulate. There are different ways to simulate a circuit. For example, let's choose DC sweep, voltage source we have, and linear sweep type. The name of the source is V in. And the start value, let's make it 0, and end value, let's make it 10. And with increments of 2. Say OK, this is DC sweep. There are others, transient and AC sweep, that will be used in our lab, and maybe others can also be used. Let's say close, and I can simulate now. It says you should save it. I say OK, and name this one as test 1. Save it. As you can see, nothing comes up. This is because we have some errors. As you can see here, it says node V in is floating and node V out is floating. This means you need to connect a ground. Without ground, we cannot make any simulations. So I should put a ground where we were putting our from here. I can say just E ground. This is earth ground because that's why there is E in front of it. E ground here. I double click and put our ground here. Now when I simulate, we should have some results. Here there is a plot, but nothing. There is no information here. In order to get any output from here, I should use one of those markers. For example, voltage marker or current marker. Let's use a voltage marker here and put our marker here. Now I should see, since this is active, I directly see the outputs here. As you can see, it starts from 0 and goes to 10 volts here. This is most basic circuit that we can use. So let's add another component to here. I just click, if you click a wire and click delete in your keyboard, it will delete it. So I will add another component, which is capacitor. Actually, it's C. I say place part not one. Why place? Okay. I click Control R to rotate it, and I right click to get rid of this capacitor, and I should connect them with wires. And also another important point, when you get a new component, for example, I want to add another capacitor. If I directly put it on a wire, then since it will get on top of each other, I should not do that. I should first delete this wire and then put the component. Should keep this in mind. After that, let's we can also change the value of our capacitor, but let's leave it as 1 nanofarad. Name is C1. Then, in addition, I can use another different voltage source. Let's, for example, delete this and use another voltage source. When I click V, there are lots of voltage sources here, different voltage sources. Let's use V sine, which will produce us a sinusoidal input. Close. Call this V in. Say OK. And there are some, when you double click on a component, there are some attributes of those components for all of them. For this sinusoidal voltage source, there are also some parameters. For example, DC, AC, there is V off. Let's make this 0. And I should say save attribute. Then its amplitude, let's make it 1, save attribute, and let's make 100 Hertz frequency. If I say nothing, then it is Hertz just. If I say, for example, M, then it is megahertz, but there is no it, so let's make it 100 Hertz and save attribute. Then I say, okay, everything is ready. Let's just simulate. Okay, close this one, simulate it again. Now this just found this voltage, but since this is just V in, now the reason why we are getting the same result is we have not changed the setup. We should change the setup from DC sweep to, for example, transient. Let's make a transient response, get a transient response of 50 milliseconds with step ceiling 0.1 milliseconds. I say just okay and close. When I simulate, I can see a sinusoidal wave. Okay. This is, for example, let me show you some tricks that you can use on this simulation. For example, you can add another trace. Let's, for example, when you click on this window and then to click trace, it will add a new trace on this window. When I say add trace, another window come up, and these are all output variables that I can use as to simulate. For example, let's do what V input, for example. Not V in, but let's look at first I should delete here. Whatever trace expression here, it will plot this one. If I click many times, a lot of things will come. So I just click, for example, IV in, current on our voltage source. When I look at this one, as you can see, it looks like it is 0. However, it is actually not. So how will I see these two plots at the same time? What I can do is I can add another axis. For example, I can add y-axis to show two different plots. Since I have millisecond, I have time axis, it's same. I can use add y-axis. This is another axis. So this one is for first one, and this one is for the second one. So how will I do that? I will first, let's clear this. What I can do is trace, delete all traces, then trace. I click here. Now this double arrow shows that I'm at second plot. I say add trace and V out. Okay. Now this is 1 volt, a sinusoidal wave. Now I also want to see the current, for example. Then I click here. This is for the first one. I say trace, add trace, IV in. This is wrong. IV in. I say okay. Now as you can see, it is 1 microampere. This is also sinusoidal, but the value of red is this first one. They correspond to the first axis, and the second axis are for green ones. For example, I can change if like, do you want to have better representations in your documentation, for example, lab reports, you can right click and say properties. This is for red one. I can change color and I can change the width. For example, let's make it the width bigger, higher. Here, for example, you can play with these properties. There is also another way to show your plots. I will show it in the second example. Let's close this one for now. This is AC. This is a transient response. We can change this one with AC sweep. I change it with decade because I want the frequency axis to be AC sweep. In AC sweep, we will see the frequency response, and I want it to be logarithmic. So I changed this to decade. Let's have 101.6 enough. It starts with from 10 kilohertz, 10 hertz, and let's make it to 1 gigahertz. I just say okay and close. Now I have also AC sweep, and I close transient. Then if I do simulation, we again cannot see any results because even though we have changed our setup to AC sweep, we have not added any AC component to our voltage source. So I will also change this to 1, and now we have 1 volt of AC, alternative current. Alternating current. Okay, save at the revert and okay. Now when I simulate, as you can see, this is the V out. Let's change this to see the magnitude. Actually, I will say trace and delete all trace, trace, add trace. I will make this, I want to see in dB. There are some functions you can use here, and I will say V out divided by V in. Okay, this one. Okay, this is actually we calculate and directly plot this one as the result. I say okay, and this is our magnitude graph. Also, I can show the phase, for example. I want to show the phase. So if I plot the phase on the same graph, it will be very meaningless. So I will add a new window to here. From here, I say add plot to window. So this is I will add a plot actually into the same window. Then I click here I click on this plot and plot and trace, add trace. And this time I want to plot the phase. So there's lots of function here you can use. For example, power, minimum, maximum, logarithm. I use phase, and I will divide V out to V in to find the phase of this circuit. I say OK, and here our phase. Again, you can change properties, for example, but you should click on here on our line. You can change color pattern. Let's make it like this and make it bold. Okay, different colors. Beautiful reports. Now I can also get a cursor here. Using this cursor, you can find exact numbers for your results. For example, this is here. Here, for example, 127. And if I click here, it will give, this will be stable in here, and I can find another point. For example, here, different points. This is for this plot. In order to find in this bottom one, I should click here, click on the second plot, and click cursor again to find the results on this graph, on this plot. Lastly, let's say you want to use this plot for your report, for your lab report. In here, there is window, and you can click on copy to clipboard and say OK. This is I have copied, and I just come here and I just say Control V, and I paste it here. This is This is better to use in your reports. That's it actually. I hope this was helpful tutorial for your lab work. See you in labs.